Good morning, my students. Today we will discuss together the last part in our lesson, quadratic functions. Our objective for this video is how to solve a system of inequalities. A system of inequalities. A system means not one inequality, two or more inequalities. It is required from you now two or three inequalities. We will remember together how to solve the quadratic and linear equation. I will remind you that solving means finding the value of the variable. This is the meaning of solving. Quadratic second degree, linear first degree. To solve a quadratic equation by using delta or calculator, we can find the root. By solving linear equations, we put x in one side or the variable, and in the other side we put the numbers. Also, we will remember together how to study the sign of linear and quadratic function. Studying the sign of linear function, we first find the root, then we draw the table, and we start with opposite sign of a, and then at the root, after the root, it will become same sign as a. For a quadratic function, we find the roots by delta or calculator. Then we draw the table of sign according to delta. If delta greater than 0, we have two roots. Inside the root, opposite sign of a, and outside same sign as a. If delta equal to 0, the sign is same and at the root is 0, and if delta less than 0, the sign is same as a. This is briefly. Let's start together how to solve the system of inequalities. First of all, I will give you a hint what I mean by system of inequalities. System means two or more inequalities. Let's say two inequalities. This is the first one, inequality, and you know it has the following sign, one of the following signs, and this is the second inequality. This is the first one, and this is the second one. If we solve the first one, we will get solution 1, and if we solve the second one, we will get solution 2. But in system, I don't want solution 1 only or solution 2 only. I want common solution for these two solutions. Let we call it as. Now I will give you the steps. First of all, we will solve the first inequality. We take the first inequality and solving it. How to solve it? As we did in the homework yesterday, first we put it equal 0, then we will find the roots, then we will draw the table, then we will find the solution as interval. This is for the first one. We get now solution 1. We then do the same steps for the second inequality to solve it, making it 0, finding its root, draw table of sign, and finding the solution. And now we get solution 2. Now we have solution 1 and solution 2. We want to get a common solution for the two inequalities. I want to give you a note. If you have two or more conditions and you want to get one condition from them, That means if I have first solution and I have second solution and I want from them the common solution, then you have to represent them on number line. On what? On number line. The number line will give you clearly the common solutions between them. So first we will solve the first inequality, we will get solution 1. We will solve the second inequality, we will get solution 2. We will represent solution 1 and solution 2 on number line, and we will choose the common region or solution for between the two solutions. And I wrote for you the note. If we have two conditions or more and we want to change them to one common condition, then we will draw a number line. I will help you to understand more by giving you an exercise. This is the first exercise. It is a system of two inequalities. This is inequality 1. This is inequality 2. First of all, I will solve the first inequality. It is x squared minus 14x minus 15 less than or equals to 0. I want its solution when it is negative or 0. As we have said before, this function may be positive, may be negative, may be 0 according to the value of x. So we will study its sign by finding the roots and draw the table of sign. Because it is quadratic, I will use calculator, or you can calculate delta. I will enter in calculator a1, b minus 14, c minus 15. The calculator will give me x prime 15, x double prime equals minus 1. Now I will draw the table of sign x from minus infinity to plus infinity. I will arrange the root from the smallest to the biggest, and here the function I want to study its sign. It has two roots, so delta is positive. At the roots its value is 0, and because delta is positive, inside the root opposite sign of a, and outside the root same sign as a. A is the coefficient of x squared. Its sign is positive, inside the root negative, and outside the root positive. As you see, this table gives you the three signs for this function: positive, negative, and 0. But I want negative or 0. So this is the negative sign from minus 1 to 15. And because we have or equals to 0, so we will have a closed interval at minus 1 and 15. So the solution 1, or the first solution, from minus 1 to 15 and minus 1 and 15 are included, closed interval. Now I will go to solve the second inequality. It is x squared minus 18x plus 17 greater than 0. Here I want the values of x when it is positive, so I will draw the table of sign. The first step is to solve it by delta or calculator. I will use the calculator and enter a1, b minus 18 and c 17, and the calculator gives me x prime equals 17, x double prime equals to 1. I will draw the table of sign x from minus infinity to plus infinity. I will arrange the roots from the smallest to the greatest one, then 17, and we have x squared minus 18x plus 17. At the roots, it has two roots, then delta greater than 0. At the roots it is 0, its sign is 0, inside the root opposite sign of a, and outside the root same sign as a is positive, inside the root negative, and outside positive. Now I want the positive sign, it is here. This is the first one and this is the second one, but keep in your mind we don't have or equal, so the intervals will be open. So the solution 2 for this inequality is the first plus from minus infinity to 1 open interval, because we don't have or equal 0, and at minus infinity and plus infinity we have said it is always open interval. Union, the second positive is from 17 to plus infinity. Now as you see we have solution 1 and solution 2, and we will represent them on number line to get the common solution. This is the number line. This is 0 from minus infinity to plus infinity. We have the first solution, let's say from minus 1 to 15. Here plus infinity, sorry. This is the first solution. How to represent it? I will use another color. From minus 1 to 15. This is solution 1. I use, it is a closed interval, so I put this line, not dotted line. Now I will go to the second solution. The second solution from minus infinity to 1. This is minus infinity, let's say this is 1. From minus infinity to 1, because it is open interval, I will put it dotted line because it is open. This is from minus infinity to 1. Union from 17 to plus infinity. This is 15, 16, 17. And because it is open interval, I will put it dotted line. This is 17 to plus infinity. This is solution 2. Solution 1 in purple color and the solution 2 in red color. Now to get solution, the common solution, it is solution 1 intersection solution 2. Now I will look for where the two solutions are intersected or the two lines are parallel. Here in this region we have the red and the purple. Here we have the purple and but we don't have the red. Here we have the red but we don't have the purple. Here we have the red but we don't have the purple. So this is the common region, the common solution here. Red and purple. So it is from here, which is minus 1 included, to here. Here what? 1 to 1. But at 1 it is dotted, so it is open, and this is the common solution. Now we will solve another example. This is system of inequalities. This is the first inequality and this is the second inequality. We will find solution 1, we will find solution 2, and then representing them on number line to get the common solution. Let's now solve the first inequality, which is x squared plus x minus 2 greater than or equal to 0. We want the values of x when it is positive or 0. So we will need table of sign. It is quadratic. Then we will solve it by delta or calculator. I will use calculator and I will enter now A equal 1, B equal 1, and C equals minus 2. We will get x prime equals 1, x double prime equals minus 2. That means two distinct roots, and you will conclude that delta is greater than 0. I will draw the table of sign x from minus infinity to plus infinity, and I will arrange the roots from the smallest to the greatest, and this is the function that I will study at sign. At the root, surely we will have the value of the function 0, and because it has two roots, then we conclude that delta is positive inside the root opposite of A, and outside the root same sign as A is positive inside the root negative, and outside the root positive sign. Now we want the sign positive or 0. This is positive, this is positive, and at the 0 I will fill it to remember that it is closed because we have or equal to 0. So the first solution is from minus infinity to minus 2 included, union from 1 included to plus infinity. And we have said that at minus infinity, plus infinity, and shaded, we always have open intervals. Now I will go to the second inequality. Second inequality is 2x squared minus 5x minus 3 less than 0. We want the negative sign. It is quadratic. I will solve it by using calculator. I will enter A 2, B minus 5, C minus 3. We will get x prime equals 3, x double prime equals minus half. Now we will draw the table of sign. X from minus infinity to plus infinity, we have minus half and then 3, and this is our function. At the root we have 0, we have two roots, then delta greater than 0. So opposite sign of A inside the roots and same sign as A outside the root. A is a positive, so inside the root we will have negative, and outside we will have positive sign. Now I want only the negative sign. This is the negative sign. It is from minus half to 3. Then solution 2 will be from minus half to 3. Now the interval is open because we have less than, we don't have or equals to 0. Now we will represent the two solutions. This is the first solution and this is the second solution. I will represent them on number line. This is the number line from minus infinity to plus infinity, and this is the 0. The first solution is from minus infinity to minus 2, this minus 1, minus 2. Minus 2 is included. This is from minus infinity to minus 2. Then from 1 2, 1 included, 1, 2 plus infinity. This is solution 1. Here, from 1 I will write it here to be clear. Now I will represent the second solution. It is from 0.5 to 3. Here minus 0.5, it is dotted because it is not included. Here minus 0.5 to 3. This is 1, this is 2, this is 3. It is also dotted because it is open interval. This is the second solution in yellow. Second solution. Now we want to find the common solution. The common solution where the two lines are found at the same times are, or we can say they are parallel, or you can say they are found at the same time. Here the only blue color, there is no yellow. Here only yellow, there is no blue. But here look, we have the two colors. They are parallel or they are found at the same time. Here is only the blue color, so this is the solution, the green region. It is from 1 to 3. So the solution, the common solution as 1, intersection as 2. From 1 included, 3 is dotted, so it is open. The third example will be homework for you, inshallah. This is the first inequality. You have to solve it. This is the second inequality. Get solution 1, get solution 2. Represent them in on number line to get the common solution. But I want to give you a hint here. You will enter to calculator 0.25 minus 1 because the coefficient of x square is 1 over 4 and 1 over 4 is 0.25. Please try to solve this system, and hope to see you soon. Thank you.